Tonight we are going to take a slow walk across the entire universe. We will begin close to home, with the warm star that lights our days, and we will travel outward step by patient step, past the planets, beyond the edge of our solar system, through the stars of our own galaxy, and finally out into the vast dark ocean of galaxies that stretches farther than the mind can easily hold. Along the way, we will meet quiet giants and violent furnaces, frozen worlds and collapsed stars, and we will try to feel, just a little, the true scale of where we live. The universe is not a cold and empty place. It is busy, structured, and astonishingly old, built over nearly 14 billion years from the simplest ingredients into something capable of asking what it all means. So settle in, breathe slowly, and let us leave the ground behind. Our first stop is the nearest star of all, the one whose light is touching you right now. The sun is the heart of everything in our neighborhood. It is a vast sphere of glowing gas, about 1.4 million kilometers across, wide enough to hold more than 1 million Earths inside it. Deep in its core, under crushing pressure and temperatures near 15 million degrees, hydrogen atoms are squeezed together into helium in a process called nuclear fusion. Each second, the sun converts millions of tons of matter into pure energy, and that energy slowly works its way to the surface before streaming out as the sunlight we feel. That light takes about 8 minutes to cross the 93 million miles to Earth, which means we always see the sun as it was 8 minutes ago. The sun holds more than 99% of all the mass in the solar system, and its gravity keeps every planet, moon, comet, and speck of dust circling around it. It has been shining steadily for around 4.5 billion years, and it has roughly 5 billion more to go. Everything we are about to explore orbits this single, ordinary, extraordinary star. Closest to the sun lie the 4 rocky planets, small, dense worlds made of metal and stone. Mercury comes first, a scorched and cratered globe with almost no atmosphere, where days are blistering and nights are bitterly cold. Then comes Venus, nearly the same size as Earth, but wrapped in a thick, toxic blanket of carbon dioxide that traps heat so fiercely that its surface is hotter than an oven, hot enough to melt lead. Venus is the hottest planet of all, even though it is not the closest to the sun. Third is our own Earth, the one world we know that holds liquid water on its surface and teems with life, a pale blue point shielded by a thin and precious atmosphere. Fourth is Mars, the red planet, a cold desert world streaked with ancient dry riverbeds and crowned by the largest volcano in the solar system. These 4 inner planets are the solid ground of the solar system, the places a spacecraft could one day land. Beyond them, the character of the worlds changes completely. Past Mars lies a great gap, and then the realm of the giants. Jupiter is the king of the planets, so massive that all the other planets could fit inside it with room to spare. It is a swirling ball of hydrogen and helium with no solid surface, ringed by storms that have raged for centuries, including the Great Red Spot, a tempest larger than the entire Earth. Next is Saturn, famous for its breathtaking rings, which are not solid at all but countless billions of pieces of ice and rock, some as small as grains of sand, orbiting in a thin and shining disk. Further out lie Uranus and Neptune, the ice giants, colder and bluer, made of water, ammonia, and methane, with winds that scream faster than any storm on Earth. Uranus is tipped almost completely on its side, rolling around the sun like a ball. Each of these giants is circled by a small family of moons, dozens of them, some of which are among the most intriguing places in the entire solar system. The planets are not alone. Circling them are moons of stunning variety, some larger than the planet Mercury. Jupiter's moon Europa hides a deep ocean of liquid water beneath a shell of ice, an ocean that may hold more water than all of Earth's seas combined. Its neighbor Io is the most volcanically active world we know, its surface constantly reshaped by erupting lava. Saturn's moon Titan has a thick golden atmosphere and rivers and lakes, not of water, but of liquid methane, the only other world with stable liquid on its surface. Far beyond Neptune lies a vast, cold zone called the Kuiper Belt, a ring of icy bodies left over from the birth of the solar system. Pluto orbits here, once counted as the 9th planet and now known as a dwarf planet, a small frozen world with mountains of ice and a faint heart-shaped plain. Out here the sun is just a very bright star, and these frozen frontiers mark the quiet outskirts of our home system, the doorway to interstellar space. To understand the wider universe, we must understand stars, because almost everything is built from them. Stars are born inside enormous clouds of gas and dust called nebulae, some of them light years across. Within these cold clouds, gravity slowly gathers material into dense clumps. As a clump grows, it heats up, and when its core becomes hot and dense enough, nuclear fusion ignites and a new star begins to shine. Stars live for millions or billions of years, balanced between gravity pulling inward and the energy of fusion pushing outward. But no star lasts forever. A star like our sun will one day swell into a vast red giant, then gently shed its outer layers, leaving behind a small, dim ember called a white dwarf. The most massive stars die far more dramatically. They collapse and then explode in a supernova, briefly outshining an entire galaxy and scattering newly forged elements across space. The iron in your blood and the calcium in your bones were forged inside ancient stars. We are, quite literally, made of stardust. When the most massive stars die, they can leave behind the strangest objects in the universe, black holes. A black hole forms when a giant star's core collapses so completely that nothing can stop it, packing an enormous amount of matter into an unimaginably small space. The gravity becomes so intense that beyond a boundary called the event horizon, not even light can escape. That is why a black hole is black. It emits no light of its own, and we detect it only by its powerful effect on the matter and stars around it. Some black holes are a few times the mass of our sun. Others, lurking at the centers of galaxies, are supermassive, millions or even billions of times heavier. Our own galaxy hosts one such giant at its center, a black hole about 4 million times the mass of the sun. In recent years, astronomers even captured the first direct images of the glowing rings of matter swirling around these monsters. Black holes warp space and time itself, the universe at its most extreme. Our sun is just one star among an enormous family. It belongs to the Milky Way, a great spiral galaxy containing somewhere between 100 and 400 billion stars. If you have ever seen a faint, milky band of light arching across a truly dark night sky, you are looking edge on into the disk of our own galaxy, at the combined glow of countless distant suns. The Milky Way is shaped like a vast pinwheel, with curving spiral arms wrapped around a bright central bulge. It is so wide that light, the fastest thing there is, takes about 100,000 years just to cross from one side to the other. Our sun sits far out in one of the spiral arms, a quiet suburb of the galaxy, and it takes around 230 million years to make a single orbit around the galactic center. The last time the sun was in its current position, dinosaurs were just beginning to appear on Earth. And our galaxy, immense as it is only one among many. Step back far enough, and even our giant galaxy becomes a single point of light. The universe contains billions upon billions of galaxies, each one a separate island of stars. Some are graceful spirals like our own. Others are vast smooth ellipticals, or ragged irregular shapes torn by collisions. Galaxies are not scattered randomly. They gather into groups and clusters, and those clusters link together into immense filaments and walls, with great empty voids between them, a structure often called the cosmic web. Our Milky Way belongs to a small group called the Local Group, and our largest neighbor, the Andromeda Galaxy, is so far away that its light takes about 2.5 million years to reach us. When you look at Andromeda, you see it as it was before modern humans existed. And astonishingly, Andromeda is slowly falling toward us. Billions of years from now, the two galaxies will gently collide and merge into one. On these scales, the everyday world disappears, and we begin to glimpse the universe as a single, breathing whole. It is almost impossible to truly feel how large the universe is, so let us try gently. Light travels about 300,000 kilometers every second, fast enough to circle the Earth 7 times in one heartbeat. Yet at that speed, sunlight still takes 8 minutes to reach us, and over 4 years to reach the very next star. Light from the center of our galaxy left about 26,000 years ago. Light from Andromeda left over 2 million years ago. And the most distant galaxies we can see shine with light that has traveled for more than 13 billion years to arrive here tonight. This means that to look out into space is to look back in time. We can never see the universe as it is right now, only as it was when each beam of light began its long journey. The observable universe stretches more than 90 billion light-years across, and within it, the number of stars is greater than every grain of sand on every beach on Earth. We live on one small world, circling one ordinary star in one of countless galaxies. All of this immensity had a beginning. About 13.8 billion years ago, the entire universe, all of space itself, was unimaginably hot and dense, and then it began to expand in an event we call the Big Bang. This was not an explosion into empty space. It was space itself stretching and cooling everywhere at once. In its first moments, the universe was a featureless soup of energy. As it cooled, the first simple atoms formed, mostly hydrogen and helium. Gravity slowly drew that gas together, lighting the first stars and assembling the first galaxies. Generation after generation of stars forged heavier elements and seeded them into space, building the carbon, oxygen, and iron from which planets and eventually living things would be made. And the universe is still expanding today. Distant galaxies are drifting ever farther apart, carried along by the stretching of space. We are not at the center of this expansion. From every galaxy, the view is the same. The cosmos is a story still being written, and we have arrived in time to read a single page of it. We began beside our own warm star and traveled all the way to the edge of the observable universe and the first moments of time itself. Along the way, we passed rocky worlds and frozen moons, watched stars be born and die, looked into the darkness of black holes, and counted galaxies beyond all counting. And yet here we still are, on a small blue world, made of atoms that were forged inside ancient stars, somehow able to look up and understand a little of where we live. That, perhaps, is the most wonderful thing of all. The universe became aware of itself through us. If this quiet journey through the cosmos gave you a moment of peace or wonder, please take a second to like this video and tell me in the comments which part of the universe you would most love to visit. Subscribe to come along on the next calm exploration, because the night sky always has more stories to tell. Thank you for spending this time among the stars. Until the next journey, take care of yourself. This was News, Cues, and Views.